So good afternoon. This will be Unit 4. We're going to do Lesson 1 today on composite functions. This is from Chapter 6, Section 1. So in algebra, two functions can be put together in such a way to create another function. As we talked about earlier, we've done in Unit 2, I believe we added, subtracted, multiplied, and divided functions. Now, we're going to do what's called a composite function. So composite function, it's kind of a mouthful, but we'll do what we can to kind of lay it out for you here. So composite function, essentially what happens here is one function is substituted in for x in the second function. So we have these two functions. One function is actually substituted in for x in the second function. This is where it gets tricky because we're replacing x with an entire function instead of just a number. So some of the notation you're going to be seeing is you're going to be seeing this notation here. So this kind of reads as f of g of x, or more commonly, I'm used to seeing it more like this, f of g of x. So as I said, this is read as f of g of x. That's kind of how we do this. Or again, in this notation, I would just say f of g of x. So again, essentially what this means is f is composed with g. So composed kind of means made with. So f is composed or made with g. As I said, when working with functions, we created new functions using these operations, adding, subtracting, multiplying, dividing. So if we were given f of x equals 2x squared minus 3 and g of x equals 4x, we've kind of already added functions before. So if I want to do f plus g, we know all we got to do is add the 2x squared minus 3, and we're going to add that to 4x. So in adding those two functions, there's really aren't any like terms, but we can rearrange the terms so they're in highest degree to lowest degree order. So the quadratic term would come first, the 2x squared. The linear term, the 4x, and the minus 3 would come in behind that. So that would be f plus g. F times g kind of means to multiply the two functions together. So notice that this is a solid dot. So it actually implies multiplication. So here we'd have f times g. But if I look at the two functions, I'd rather multiply the f of x, the 4x first. So I'm going to mentally rearrange it as 4x times 2x squared minus 3. Because remember, f times g is going to be the same thing as g times f, because order doesn't really matter in multiplication. So that would be our function. Now, what we typically do, though, is we usually multiply this monomial using the distributive property. We multiply it through the binomial there. So if we multiply 4x times 2x squared, we're going to get 8x cubed. And then if we multiply 4x times negative 3, we're going to get this negative 12x. So that would be our function f times g. And if you recall, we also kind of evaluated f plus g when x equals negative 3. So this kind of represents this f plus g of x. So now they're giving you a value for x to substitute the function. So our function was this 2x squared plus this 4x minus 3. That was f plus g. We've already done that math. And all we're really doing now is replacing x with negative 3. So this becomes then 2 times negative 3 squared plus 4 times negative 3 minus 3. So notice how we substitute the negative 3 in for x. And if we follow the order of operations, we have to square the negative 3 first. So it's going to be 2 times 9 plus then 4 times negative 3 minus 3. And then we have to multiply x. So that's going to be 18. And that's going to be a negative 12 minus 3. And I would go ahead and put the negative numbers together. So I'd have a 18 and a negative 15. And so that would make then a 3. So f plus g of negative 3 there would actually give us a 3 as an answer. If I want to evaluate f times g of 0, remember our function was 8x cubed minus 12x. So to evaluate f times g of 0, what we do is we replace x with 0. We substitute 0 in for x. So it's going to be 8 times then this 0 cubed minus 12 times 0. If we follow the order of operations, we have to cube the 0 first. That's still going to be 0. And we're going to have 8 times 0 minus 12 times 0. So it's going to be 0, take away 0. In other words, our final answer is 0. So f times g of 0 actually turns into 0. So we did that back in Unit 2. So today we're going to be working with composite functions. And remember, a composite function, we're substituting one function into another. First thing we want to do in this example, though, is we want to actually evaluate a composite function. So if I want to evaluate f of g of 2, one way to do this is I can write this as f of g of x to start with. And if I want to evaluate f of g of 2, we work inside out. So we replace x with the 2. So we will then have f of g of 2. So what we have to do now is actually we have to evaluate g of 2. So to do that, we have to know what the g function was. Notice the g function was 4x. So remember, g of x is equal to 4x. So g of 2 means to substitute 2 in for x and evaluate. That's going to be 4 times 2, which is going to then be, so g of 2 is actually going to equal then this 8. So what I can do now is I can replace g of 2 with 8. So this now becomes f of 8. So to evaluate f of 8, I have to know what the f function was. So that was 2x squared minus 3. So what we do is we substitute 8 in for x. That becomes then 2 times 8 squared minus 3. And if we follow the order of operations, we have 8 squared to deal with first. That's going to be 2 times 64. And then we're going to subtract 3. And then that's going to be 128. And we're going to be subtracting 3. So therefore, our final answer is going to be then this 125. So f of g of 2 would equal then 125. Now, basically, this model here, that's kind of what we call our function model. So I'm going to call this g of x here. And this is going to be f of x over here. So notice that to evaluate this, we first have to evaluate this g of 2. So notice that 2 would actually have to be fed into this function. And this function says multiply the 2 by 4. And 4 times 2 turns out to become then this 8. So what happens next, though, is this 8 has to then come over here and be replaced. It has to be substituted into the f function. So it becomes the new input value. So that's where this 8 happens. This 8 now has to go into this function. So that means you have to replace that x with that, and you have this 2 times this 8 squared minus this 3. And out came then this 125. So we have to feed 2 models here. We have to feed the g function model, which then feeds into the f of x model. So let's look at another example. So if I want to evaluate g of f of 3, again, this is a composite function concept. So again, I'm going to write this as g of f of x. Now, to evaluate g of f of 3, the x is going to get replaced with this 3. So this becomes then g of f of 3. So to evaluate this, we actually have to evaluate the f function first. And we know that x has to be 3. So this becomes then f of 3 is going to equal then this 2 times this 3 squared. And then what was the rest of that? I can't remember now. 2x squared minus 3. So 2 times 3 squared minus 3. So if we follow the order of operations here, we have 2 times 9 minus 3. That's going to be 18 minus 3, which turns into this 15. So this turns into then g of 15. So now the 15 has to go in for x in the g of x function. So it's going to be 4 times 15. 4 times 15. So 4 times 15 turns into then this 60. So g of f of 3 is going to equal then 60 as an answer. So the next thing we want to evaluate is one that looks like this, f of negative 1. So this really is f of x. So my first move is to evaluate f of negative 1. So this becomes then f of negative 1. So the negative 1 has to go in for x in the f function. So this becomes then 2 times negative 1 squared minus 3. So then we perform the order of operations. Negative 1 squared would be 1. 2 times 1 minus 3. We have to multiply 2 minus 3 now. And 2 and a negative 3 becomes then this negative 1. So f of negative 1 becomes then negative 1. So now I have f of negative 1 again. So we've already done that math. So that's just going to equal then this negative 1. So we don't have to do that again. So f of negative 1 would just be negative 1. So I could write this f of negative 1 would be then negative 1. So something else we're going to be doing is we're going to be creating a composite functioning and determining the domain. So yeah, we're going to be working with domain and range a little bit again in the upcoming sections. This again is talk about domains. Remember, there are two situations that have domain restrictions. So remember, one of them is the denominator cannot equal 0. And there cannot be a negative number inside the square root symbol. So remember, the square root symbol looks like this. And the denominator means you have to have a numerator and a denominator. So the denominator is the bottom part of a fraction. So that's only 2 times we have a domain restriction. If we don't see a denominator, if we don't see a square root symbol, at this point, we would say there is not a domain restriction. So suppose we have the function f of x equals x squared minus 3x plus 1. Recognize that is a quadratic. And remember, quadratics do not have a domain restriction. G of x equals 2x minus 3. You should recognize that as a line, and a line does not have a domain restriction. And remember, if there's not a domain restriction, the domain is the set of all real numbers. So what we want to do next is we want to create the composite function and then determine the domain. So if I want to create the composite function f of g, this is going to be the same thing as f of g of x. So this notation is a little bit clearer for us. So again, f is going to be composed by g. So what happens is g of x is going to have to be substituted into the f of x function. So notice that g of x is going to be this 2x minus 3 over here. So this 2x minus 3 is going to replace g of x this time. So this is going to be f of 2x minus 3. Now the catch now is the 2x minus 3 has to be substituted in for x in the f function. So this is where it gets tricky, because now I have to replace x with the actual g function, which is 2x minus 3. So this becomes 2x minus 3 squared minus then 3 times this 2x minus 3. So notice how we have an x here, and we have an x here, and that 2x minus 3 has to go into both spots. And then we have this plus 1. So if I evaluate, or I'm sorry, simplify this, remember a binomial squared, I'm going to use the shortcut. A binomial squared creates a trinomial. And the way we do this is we just square the first term. 2x times 2x would be 4x squared. And then we multiply the first and the last terms together. So 2x times -3 is going to be -6. And then we double it. That's going to be a -12x. And then we square the last term. A -3 times -3 is a +9. So that gives me that. So I don't have to use FOIL. I can just use the shortcut. So the next thing is I have to multiply the -3 through the parentheses. So -3 times 2x is going to be -6x. And -3 times -3 is going to be a +9. And then the +1 comes on down. So we're one step closer to finishing this off. So the quadratic term is by itself. So the 4x squared stays put. But notice how the -12x, we have a -12x here and this -6x, they have to go together. So that's going to give me this -18x. And then we have this 9, and this 1 kind of go together. So 9 and 9 is 18 plus 1 more is 19. So we end up with then 4x squared minus 18x plus 19. So that would be our new function. And the domain, again, there's no domain restrictions along the way. There's no numerator, there's no denominator. So the domain is the set of all real numbers, or using interval notation, we're going to say -infinity to infinity is the domain. So the next example is I want to find the composite function g of f. So this now becomes g of f of x. So notice how the first function stays on the outside, the second function goes on the inside. So g of f of x. So in this one, we have to identify what f of x is. So f of x is this x squared minus 3x plus 1. So this turns into g of x squared minus 3x plus 1. What happens though is I have to replace x in the g of x function. So what we have to pick up on is this here has to go in place of this x in the g function up here. So what we do then is we have 2 times x squared minus 3x plus 1. That goes in for x. And then we have this minus 3. So we have that expression. So our next move is to remove the parentheses by multiplying the 2 through the parentheses. That's going to be 2x squared minus 6x plus 2. And then we have this minus 3. So notice how the only like terms are the 2 and the -3. So this becomes then 2x cubed minus 6x minus 1. That becomes the g of x function, the g of f of x function. So again, this would be f of g would equal that. And this would be g of f would equal that. Now the domain, again, there is no domain restriction. So the domain, again, is going to be the interval from -infinity to infinity if I'm using interval notation. So the set of all real numbers. Showing that 2 composite functions are equal. So as we move into the next lesson, we'll have to evaluate f of g of x, and we'll have to evaluate g of f of x, and we want to show that they're equal. To show that they're equal, when you evaluate them, we should get the same answer. So what we want to do is we want to see if f of g of x and g of f of x are equal. To do that, we're going to evaluate f of g of x and g of f of x. So let's start with f of g of x. So again, I'm going to use this notation, f of g of x. So that means I'm going to replace g of x with x plus 4 over 3. So this becomes then f of x plus 4 over 3. So what happens is we have to now put x plus 4 over 3 in for x in the f of x function. So we got to pick up on is this whole thing here is going to go in place of x up here. So this becomes then 3 times x plus 4 over 3 minus 4. To evaluate this, or simplify, I should say, notice how the 3 on the top and the 3 on the bottom just divide out to start with. This leaves me x plus 4 minus 4. And the plus 4 and the minus 4 cancel out as well. So now we're just left with x. So that's what f of g of x equals. Now what we want to do is we want to evaluate g of f of x. To do this, we now have to identify what f of x is. So it's going to now be g of 3x minus 4. This 3x minus 4 is now going to go in place of x in the g function. So again, this part here is going to go in place of x in the g function. So this becomes then 3x minus 4 plus 4 over 3. So to simplify this, we have to simplify the numerator first. The negative 4 and the 4 would zero out. That gives me 3x over 3. The 3's would then cancel out, and now we have just x. So what we pick up on then is g of f of x also equals x. And since they both equal the same thing, we can then make a conclusion then, therefore, f of g does equal g of f because they both equal x. So that concludes our lesson on composite functions.